Welcome to our exciting journey through advanced MLOps. Today we're exploring how tech companies manage hundreds of machine learning models like master conductors leading a digital orchestra. Let's start with our first topic, multi-tenant ML platform best practices. Think of this like managing a huge apartment building where each tenant needs their own space, but they all share the same utilities. The key strategies include resource isolation using containers and namespaces, shared infrastructure with tenant-specific configs, centralized monitoring with tenant filtering, and role-based access control. Here's a fun analogy. It's like apartment building management, shared utilities, separate units, individual billing. Now, let's look at our tip section. Use Kubernetes namespaces for tenant isolation. Moving to our second question, scaling MLOps for hundreds of models. When you need to handle hundreds of models, you need smart scaling strategies. These include automated pipeline templates and generators, batch processing for similar model types, resource pooling and dynamic allocation, centralized artifact management, and event-driven architectures. Think of it like a car factory, assembly lines, shared tools, automated processes. Our tip section reminds us. Group similar models for batch operations. Now we're diving into ensemble models and managing dependencies, two crucial skills for any MLOps engineer. First up, deploying ensemble models. Ensemble models are like having multiple experts give their opinions before making a final decision. The deployment architecture includes a load balancer that distributes requests, multiple model instances running in parallel, an aggregation service that combines predictions, and fallback mechanisms for failed models. Now, let's look at our code section that shows an ensemble prediction service. Here's our analogy. Like a jury decision, multiple experts vote. Final verdict combines all opinions. Next question, managing dependencies and compatibility. This is absolutely critical in production environments. Your dependency management strategy should include Docker containers for environment isolation, version pinning in requirements files, virtual environments for each model, and dependency vulnerability scanning. Let's check out our code section showing a Docker file for model isolation. Our tip section emphasizes, pin exact versions to avoid works on my machine issues. Get ready for one of the most exciting topics, online learning. This is where your models get smarter while they're actually working. Our first topic, implementing online learning. Online learning is fascinating because your model continuously improves from new data. The setup includes a streaming data pipeline using Kafka or Kinesis, incremental model updates, an A/B testing framework, real-time performance monitoring, and rollback mechanisms for bad updates. Let's examine our code section showing an online learning pipeline. Perfect analogy time, like learning while doing, a chef adjusting recipes based on customer feedback in real time. Second question, key considerations. These critical factors will make or break your online learning system. You need data quality validation before updates, gradual rollout to prevent catastrophic failures, model versioning and experiment tracking, performance degradation alerts, and automated rollback triggers. Our tip section warns us, always validate new data before feeding to online learner. And here's another great analogy. Like traffic lights adapting to traffic patterns, smart, but with safety checks. Time to tackle the giants of machine learning, transformer models. These are the powerhouses behind ChatGPT and many other amazing AI systems. First challenge, containerizing large transformers. Deploying massive transformer models requires a special container strategy. This includes multi-stage Docker builds, model optimization through quantization and pruning, GPU-enabled base images, health checks and readiness probes, and proper resource limits and requests. Let's look at our code section showing a multi-stage Docker file. Great analogy, like shipping a grand piano, special packaging, careful handling, proper equipment. Second challenge, ensuring deterministic outputs. This means getting the same results every single time, crucial for production systems. Your determinism strategies should include fixed random seeds everywhere, consistent library versions, disabled non-deterministic operations, environment variable standardization, and input preprocessing consistency. Now our code section demonstrates ensuring determinism. Our tip section reminds us, set seeds at the very beginning of your application. We're entering advanced territory with concept drift and reinforcement learning, the cutting edge of MLOps. First topic, handling concept drift. Concept drift is when your data starts changing over time, making your model less accurate. Your drift detection methods should include statistical tests like KS-test and PSI, performance monitoring dashboards, sliding window comparisons, automated retraining triggers, and data distribution monitoring. Let's examine our code section with a drift detection example. Perfect analogy, like a surfer adjusting to changing waves, constant awareness, and quick adaptation. Second topic, deploying RL models. Reinforcement learning deployment brings unique challenges. These include safe exploration in production, real-time action selection, environment simulation for testing, reward signal collection, and policy rollback mechanisms. Our code section shows an RL deployment pattern. Our tips section emphasizes, always have a safety policy as backup. Now we're tackling one of the biggest decisions in MLOps. How often should you retrain your models? Our main topic, retraining frequency versus performance. This involves key trade-offs you need to understand. More frequent retraining gives better accuracy, but higher costs. Less frequent retraining means lower costs, but potential drift. The sweet spot is finding the balance based on business impact. Great analogy, like car maintenance, too often wastes money, too rare risks breakdown. Your decision factors include data velocity and variety, model performance degradation rate, training costs versus accuracy benefits, and business criticality of predictions. Our tips section advises, monitor performance metrics to find optimal retraining frequency. Second part, smart retraining strategies. These adaptive approaches include performance-triggered retraining, data drift-based scheduling, business calendar alignment, resource availability optimization, and A/B testing for retraining impact. Let's look at our code section showing smart retraining logic. Another fun analogy, like a circus performer, practice when needed, not by rigid schedule. We're building complete systems now. This is where everything comes together. First topic, complete end-to-end ML pipeline. A complete pipeline includes these essential components: data ingestion and validation, feature engineering and selection, model training and evaluation, deployment and serving, monitoring and alerting, and feedback loop and retraining. Perfect analogy, like a complete factory, raw materials in, finished products out, quality control throughout. Key technologies include Airflow or Kubeflow for orchestration, MLflow for experiment tracking, Docker for containerization, and Kubernetes for deployment. Our tips section reminds us, design for reproducibility from day one. Second topic, handling model accuracy degradation. When your model starts failing, you need immediate actions. Alert stakeholders immediately, roll back to previous stable version, investigate root cause like data or concept drift, implement temporary fixes, and plan systematic solution. Let's check our code section showing a degradation response workflow. Excellent analogy, like medical emergency response. Stabilize first, diagnose second, treat systematically. Now we're tackling real-world applications with serious consequences, fraud detection, and ensuring fairness. First topic, financial fraud detection MLOps. This system has strict requirements: real-time inference under 100 milliseconds, high availability of 99.9% or better, explainable predictions, regulatory compliance, continuous monitoring, and audit trail maintenance. Great analogy, like a security guard system. Always watching, quick to respond, detailed logs. The architecture includes streaming data pipeline, feature store for consistency, A/B testing framework, champion/challenger deployment, and real-time monitoring dashboard. Our tip section emphasizes, optimize for speed. Fraud detection needs real-time response. Second topic, addressing model bias. Your bias mitigation steps should include identifying bias sources and affected groups, collecting more representative data, applying fairness constraints in training, implementing bias monitoring dashboards, regular fairness audits, and stakeholder communication plan. Let's examine our code section with a bias detection example. Perfect analogy, like ensuring fair treatment in hiring, check for unfair patterns, adjust processes. We're focusing on the foundation of great MLOps, solid data, and strong teamwork. First challenge, handling delayed or corrupted training data. Your mitigation strategies should include data validation and quality checks, backup data sources and fallbacks, historical data buffer maintenance, automated data healing pipelines, and alert systems for data anomalies. Let's look at our code section showing a data quality pipeline. Great analogy, like a water filtration system, multiple filters, backup sources, quality monitoring. Second topic, cross-team collaboration. Your collaboration framework needs shared documentation and standards, regular cross-team meetings, unified monitoring dashboards, common tooling and platforms, clear ownership and responsibilities, and incident response procedures. Perfect analogy, like an orchestra, different instruments, shared sheet music, one conductor. Communication tools include Slack channels for real-time chat, Confluence for documentation, Jira for task tracking, regular demo sessions, and shared on-call rotations. Our tips section reminds us, document everything, future you will thank present you. We're optimizing for speed and automating everything, the hallmarks of professional MLOps. First topic, slow model prediction solutions. Your speed optimization toolkit includes model quantization and pruning, batch prediction processing, caching frequent predictions, load balancing across instances, GPU acceleration where applicable, and feature precomputation. Let's examine our code section showing prediction optimization. Exciting analogy, like tuning a race car, lighter weight, better aerodynamics, more power. Second topic, CI/CD with retraining schedules. Your integration strategy should include automated model testing in CI pipeline, scheduled retraining jobs, model performance gates, gradual deployment rollouts, automated rollback on failures, and performance regression testing. Our code section shows CI/CD pipeline configuration. Our tips section advises, treat model updates like code updates, test thoroughly before deployment. Our final slide covers the most valuable skill, learning from mistakes and getting better. First topic, debugging worse retraining performance. Your debug checklist should include comparing training and validation data distributions, checking for data leakage or contamination, verifying hyperparameter configurations, analyzing feature importance changes, reviewing model architecture changes, and checking for overfitting or underfitting. Let's check our code section showing performance debugging. Great analogy, like a detective investigating a crime. Gather evidence, compare clues, find the culprit. Final topic, lessons from ML production failures. Common failure patterns include insufficient monitoring leading to silent failures, data quality issues causing model drift, lack of rollback strategy during outages, feature engineering bugs in production, inadequate testing of edge cases, and poor communication during incidents. Perfect analogy, like learning from cooking disasters. Burnt meals teach you about temperature control. Prevention strategies include comprehensive monitoring and alerting, thorough testing including edge cases, clear incident response procedures, regular post-mortem meetings, and documentation of lessons learned. Our final tip section reminds us, every failure is a learning opportunity. Document and share insights. Congratulations! You've just completed an incredible journey through advanced MLOps concepts. Remember, every expert was once a beginner, and every failure is a step toward mastery. Keep learning, keep building, and keep making the world better with your ML systems.